Good morning and welcome to AP Statistics. Today I'm going to give you a quick review of what will be on your quiz tomorrow. So, on the board behind me is pretty much everything you're going to have to know. The first thing has to do with two events having a union. Now, the union of two events is the probability of one happening or the other happening. Sometimes when two events can happen at the same time, there's going to be what's called the intersection, which is next. So when you figure the union, you add the probability of the first plus the probability of the second, but you have to subtract their intersection because by adding the two together, you've double counted where they cross. So that's union. Intersection means that these two events are happening concurrently at the same time. The probability of their intersection is equal to their product if they're independent. So the probability of one intersecting the other is the probability of the first times the probability of the second. Now, we'll get to independence in a moment, but whether or not two events are independent, we can always find the probability of an intersection with this method right there. It's the probability of the first times the probability of the second given the first. That's always going to be true, with or without independence. So if you're unclear, but you have the data that supports using that formula, you always can. Mutually exclusive means that two events cannot occur at the same time. We also call that disjoint. If they can happen at the same time, we call them not mutually exclusive or joint events. Now, when two events are mutually exclusive, again, it means they can't happen at the same time, which also means that there's no intersection. So we say formulaically that the probability of A intersect B equals 0. That would indicate mutually exclusive events. Okay, back to independence. Independence really means that, again, the fact that one event occurred has no impact on the probability of the other one occurring. If two events are independent, this will be true. The probability of their intersection will equal the product of their probabilities. Now, I know I said that already up here to find an intersection because that was if they're independent, this will show you the intersection. But kind of conversely, if this is their intersection, the two events are independent. What else could you do? Well, you could use this formula right here. It's always going to work. The independence rule says if the first happens, it's going to be the same whether or not the second happened. So P of A equals P of A given B. The probability of event A occurring won't have been changed with the condition that event B has occurred. So if that's true, we also have independent events. You don't have to use both of them, but either one will work when proving independence. We'll also have to, of course, look at two-way tables, which we've done a lot of. Two-way tables are, of course, matrices of information, from which we can find the marginal distribution, which means the values that are the totals of each row in each column. We can also find the conditional distributions, which means we look at one particular row or one particular column, which is the condition. This symbol right here is the symbol for condition. So the probability of one given the other has occurred. That's a condition, and we would look at either one row or one column to find that probability. Lastly, we had Venn diagrams, which is where we have essentially two or more circles, each one representing an event, and they intersect if the events intersect. And we find probabilities and we put them in the portions of the circles where they belong. And if anything is left over, we put it outside those circles, but within a rectangle to indicate the universe of our possibilities. Okay, so your quiz is going to be on that material. It's going to be similar to other quizzes you've had, not too long, but of course do the same day it's given and hopefully before the end of the day. I'll say before 3 o'clock. That should give you enough time. Yesterday I got 0 people in my meet, which was the first time I think that's happened for your class. So it would be great if you have any questions, if you log in. All right, so log in today if there's any issues or questions about the material, the review, or the things we did before break. But if you're comfortable with everything and you're on point, that's fine. You don't have to log in. All right, any questions, let me know. Otherwise, that's all. Have a great day.